This is an introduction to the course which we talk about saying electronic enclosures and thermal issues in the electronic enclosures, and the context of the course is, if you can follow my presentation on this side, can you please show me this, sir, this monitor. You see here we have pigeonhole here. Something very positive about pigeonhole is every pigeon has a place to rest and whatever it is, and then these look a little like the white pigeons, but extreme left top you will notice two pigeons are trying to get into one opening. You have seen this. This is exactly what happens with the case of most real life products. One of the first thing is what has been shown there as pigeonholing is not valid. We end up in what is called the over the wall design. So, somebody makes something, he makes electronics, and then afterwards one group makes electronics, and afterwards it is passed on to another group to sort out the issues that may have cropped up. So, the thing what has been done here is to sensitize a core functional engineer of whatever, now the word domain knowledge is used, but I will call it whichever functional knowledge he has in one area with other areas it is. So, electronics people will be able to understand what is the mechanical and especially thermal issues regarding the physical products that come into being. Similarly, if you have manufacturing people, they should also know what and what should not be compromised when a drawing is present to them. So, that is where we have this reality of having to work with several other groups. So, I am showing for convenience sake, we have a beehive there. All of the people seem to work for a common good of the whole thing. So, it is just a allegorical representation, nothing to do, there are no bees and all that. The other thing is, in case you fail, sometimes the consequences are disastrous. At least here, you see here we have a hornet's nest. So, this hornet's nest, if somebody comes and tries to attack, you know what will happen like this. So, these are all part of it. So, we see that a product, a real life product is in the context of so many other things like this. Okay. In the earlier chapter, I talked about environmental, industrial, little bit of ergonomics, and then product positioning and profitability, aesthetics, visibility, industrial design, ergonomics, and so on. Now, as we come to the core part of it, one of the first thing you will notice is real life products like this have so many other issues. One of them is manufacturing, another is you see here, it looks a whimsical design, but if you are to go into the market and imagine this product which is looking neat and clean and you are looking for a wall clock, I am sure this makes more sense in a modern decor. I am sure you will like it, and some other things have been built into it. Is one of my students' things, none of them is mine. So, you will notice here that the important aspect of one of the important aspects of product design is how to make an enclosure here, and very much related to this enclosure is thermal. If you seal the box, you can't take the heat out, at least intuitively it feels like that. You seal a box, you can't take the heat out. You need to provide a few openings, and if you provide a few openings, all the stuff from outside gets inside. Now, you may be wondering how do all the things work. In a thing like a conventional thing like any of the domestic things inside your home, if you are to have a washing machine, you see that part which handles the liquid or the cleaning device is very separate from the electrical and other things. Usually display panel is on top, which is reasonably protected. Then you have various drum, you have a top loader or a front loader. Then you have several types of electronics and plumbing. They are all identified and generally they are reasonably isolated, can be dealt simply. But then as you keep progressing into more and more complicated things, design across this seems to be not as easy as it looks like. You have seen here. I think this may be giving you a reasonably good idea of what it is. I too have no clue what it is. It will look like maybe a gaming PC, and it says C905 something and all. And you will notice that cooling is not easy. And some other beauty also, one of the beauties you will notice is it has several unconventional, or at least what attracts your attention. You see here we have a very unconventional heat pipe which is going about its work there. Now, if if you can kindly show me this, sir, I will try to view with page width, electronics. I belong to this place from IAFC, and down if you go, most important is we have thermal design textbooks. This is where the little problem, well, I won't call it a problem, it is an opportunity for you. You can learn the fundamentals here, you understand, no? So, you have heat and mass transfer fundamental cell applications, and then good old physics. Then you have one more, recently I have found a good book which deals things reasonably well, and something else saying engineering design. These books are the what you call sort of the core of it. Now, you will see here list of references. I have also provided something which is relatively open source. So, just like that I used a what you call a WOW course, OCW, then you have YouTube videos on topics, and then very important is manufacturer's documentation. So, frequently I will be referring to the manufacturer's documentation. I think here now we have product heat sinks, blowers, coolers, mounting hardware and so on. Read it along with me, which you will be forced to do. Theory of heat transfer has been understood and explained way back in 1700. Rigor and precision has resulted in seemingly complicated equations. So, this is where the crux of the matter lies. There is a lot of industry practice by, I cannot say what it is, they have been tried to make things a little bit of understood, little bit of experimentation, little bit of trial and error. And if somebody tells you, especially one of the teachers tells you that he has invented the equations, respect him. Okay. If you do not like your teachers, you will end up being one of them and like me. Okay. The thing is, delta part of it has been then, but the basic things has been around for a very short time. More over 300 years back, anything you wanted to know has been simplified and presented like this, saying in case there is a temperature difference, there will be more heat transfer. In case there is more area of something, something else will be there, and this is the physics of reality. Then somebody has modeled them and made them equations. So, the equations are valid with all the things that they have given. So, I will now close this and try to now go back to a beautiful book here, which I suggest you people know should be able to probably see it on the internet, and if you have access, because this being an open source thing, read it for yourself. You cannot copy it and you cannot this thing. However, you see here, if you go for what you call practical thermal resistances, all this, somebody has already worked on it, including a large number of heat generation in active devices. What is it that causes this heat generation? And a little bit of I think several of us know or probably know the what do you call, there is a patent, not patent, I am sorry, there is a what do you call, CRC Press has released all this long ago. So, I have not taken any special what do you call this thing about it, but then permission from it, this is standard thing which you will find everywhere. I suggest you read the original or buy any other textbook, and since you are taking it on one of our courses, there is no exam you need to pass and nobody is going to give you, you are not going to be graded, you understand, no? I cannot be judgmental about you, I may be opinionated but can't be judgmental about you. The only thing would finally makes any impact is probably you have this beautiful phone, you have seen that, no? By itself it is a stupid clone. Do not say, sorry for my words again being unnecessary, by sticking a colorful sticker at the back does not make it anywhere near the original, but I can copy a little about how it looks, I can even copy. I can even copy the various types of tiles and all that. So, you know what the user interface is and you know you are all familiar with the sticker, but you know very well this is not the original. You will notice that somebody has spent huge amounts of time and money to optimize every aspect of this device, including we have now suddenly a fingerprint sensor and then I have a box and then I have something here and all that. Same it is with our case, and then in this case you see here we continue to have journals like this. This journal no, is a recent thing, it was made in probably 2014, okay. IEEE transactions on components, packaging and manufacturing technology. Even today if you go around and if you subscribe and if you belong to an academic place like ours, you have access to these things. In between the pages lot of things are packed. You have seen this, some of them are real. Real means if you conduct the experiment the way that has been done here, it will work very well. And secondly, somebody has already done a lot of work on how to carry out an experiment, including you have fantastic things like saying system level, system on package, L-band antenna and so on. So, in these cases you have huge amounts of information which is thermal modeling. In this, it is real thermal modeling, all this has been done and academic somebody has done worked out all the details for you. Now, when you come to a practical device, this is what I keep trying to show in my lectures. You need to use your own creativity and try to see how best you can solve the problem. If you have found out a way of configuring this device, then you can analyze it. Before that, I do not know whether anything can be analyzed. One of the peculiar questions is, you see this black stuff here and you see this something here, this beautiful colorful thing, okay. Maybe it looks a little like some device which can make ice candy, and I am sure several of you have seen this, okay. This is where the thing about conventional and non-conventional cooling comes. It looks like a little bit of what do you call, I will not call it a surplus yard. This is the reality of electronics packaging. You see this beauty? This beauty is a device which is supposed to work with 180 amps peak and 36 volts nominal DC drive. The beauty of it is it is nice, compact, and they have given a beautiful surface here. So, something is written here. So, if you I mean just like that, if you multiply say approximately 150 into this 36 volts, it comes to 5 kilowatts. That is a lot of power, is it not? Now comes the thing, does it really, the load is 5 kilowatts, okay, in the peak. Average when things run now, it may be barely about 2 kilowatts maximum, or approximately 1 kilowatt. Now the things come about where the mechanical engineer should appreciate the electronics, saying usually if you are working on part load conditions, even with switching devices, chances are you may end up with losses, and any loss ends up as heat. So, if you are to take a 1 kilowatt device and 90% efficiency, still you have 100 watts of loss. There is no way a simple plate like this can lose that heat. Now we end up with the manufacturer, usually two ways they do. They will give you with fine print, all our things are valid provided this surface is kept at 50 degrees centigrade. Now how do you keep it at 50 degrees centigrade? This is where our problem comes. Obviously, or very simple way, one of the simplest way is attach a heat spreader to it and put a fan. Looks good enough, isn't it? Small heat spreader and a fan. Alternatively, if you suspect the fan itself is going to take, I have put this monstrous thing on his, you have seen it, no? Oh, I am sorry, I put this monstrous thing on his. So, we call this, loosely it is called a heat sink. The word sink, also, there is a semantic about it, saying heat somehow keeps going off into it. It is true probably for this part of it, you understand, no? It is true for this part of the device, massive, and then afterwards you have these fins need to exchange the heat to the ambient. Now we come to the other important aspects of it. It is very heavy, you will get a muscle building thing. Instead of now putting some monster like that there, can we do something about it? Can we use something which is slightly better? And this is where it will come to the original packaging thing. This is nice, neat, sealed equipment. By default, probably it is an IP55 or IP 56 type of equipment. So, it is splash proof, and accidentally even if water falls into it, nothing is likely to happen. Next, what do we do about this small small thing which we like, which we end up mounting and all? I think my shirt will show you this, or you can see here, no? What do we do about all these things? These are all the small heat spreaders which use all the places, and not as if we have stopped it here. You have seen this, we have another very cute this thing, a shining heat spreader, and for good effect somebody has made it black. So, this lecture tries to explain to you a little more, and then as I have explained to earlier, there are no automatic questions and answers for these things. It is for you to see. Towards the end, I have shown these pictures. There is a drive, and when you open it, this is how things look like. And this again, one more thing about the orientation, how do you keep it and all that. These are little practical things which we have been implementing in our research lab for a long time. Again, this is where I have explained in one of my lectures, saying in the academic we have a search. Once you define a problem, which problem would like to study in detail, so that you can improve things in it. What do we do? First of all, we look for all the existing publications in this, or best called literature survey. You understand, no? We carry out a literature survey to see what are all the publications that are existing. Equivalent to that in our product design is prior art. Whatever you do can be, if it is not already open source and if you can justify how you have done it, you have to make sure it is already not patented by somebody else. So, one is patent search, another is prior art. How are the other people solving the similar problems? So, in the case of our product design, now if you come back to my monitor here, one of the first things are, we need to check, how are people making these things here. There is something about IP classes, and you see we have a beautiful, I do not know, some nice colorful equipment is there. What exactly is the equipment? I too have no interest, I mean sorry, though I have done it, I have to know first hand knowledge. You see here our electronics invariably ends up with being out in the open and incidentally open source. I think if you identify all the components, you will know what it could be. This one is a drive for a electric vehicle. Now, when you see if you have a drive for the electric vehicle, top you see here, this one is the raw electronic circuit which one group has developed like that. Afterwards, we took a look at it again and then we tried to package it, ended up with some things like this which are somewhat commonly used in the industry. Understand, no? The issue is they are commonly used in the industry. Now, somewhere the moment you have pins like this, it means power is taken from a source and then you have output, this is sockets. So, power is given to the other thing. So, they are all color coded and you have various things which are attached to this. I thought I will just take you here and stop it here. I will give an escape and then I will go back to the main monitor here. We have this data acquisition system which was made for a solar tiny power plant. Elsewhere, I have already, one of the lectures if you follow, I have shown you an actual installation where huge rack mounted equipment. Have a look at this. This looks a little like your, what you find usually as you enter into a room, it looks a little like your air curtain fan. In fact, you can, this is a small air curtain fan. Now, where do you use such things? So, if you have to have rows of heat sinks, probably you can use it for lifting the air. So, samples of a place where a solar installation is there, how air is, cooling air is handled, including for a large place, meaning you have something of the size of a huge building. And all the way to tiny things like how would you cool this device. While in principle it looks very nice, we have a nice simple thing. All you have to do is, if you put two of them parallel, obviously more area is available and then you can also cascade them. If you cascade them, you can get a better whatever temperature differential, but only if you consult the manufacturer's catalog, they will tell you under what conditions it can maintain these various parameters which have been taken away. If you keep it in the air like this and show you, and if you put a small thermometer and show, it is not a very reliable way. You cannot go ahead and design equipment like this. In contrast, the same device is sitting here. See this, in between it is sitting here, and one side the heat is being generated, other side we have provided a thermal mass for something. This is a biomedical equipment. So, we have something, one sample is kept here, it is heated and cooled, and this has been taken from this, whole thing is insulated, and what looks like a candy is, this is probably a urinary sample which we need to collect it, quickly freeze it, I am sorry, not freeze, keep it at a low temperature such that activity has stopped, then we have two things, one is a control, this is a control, and this one is the actual test. So, this is kept inside and this is kept inside, some various reagents are added, typically antibiotics. In the end, depending on your BMI, depending on your age and your what you call already resistance, can quickly identify which medicine works on your particular, on the target thing. And the beauty of it is things like this are not very, how do you say, not good. I am not so much convinced about it, but still they have a use for it, where you have to raise temperature beyond the, above the ambient. Similarly, quickly at a given rate you have to cool it to a different temperature. So, this is typically a Peltier or thermoelectric cooler device like this. So, this lecture has to do a little while like these things, saying how do we go around trying to understand things which are there and so on. And now go up again and then see. Okay. Now, kindly if you look at the other monitor, you will notice that using an available commercial software, I have tried to see whether we can create things like I have a heat sink there, seen it there. I have started with something which is directly available on the what do you call it is available on the proportions for this have been taken from here, seen this here. So, at the back see at the back, that is a commercial what do you call heat sink which is available. See there, the dark one is the heat sink that has been taken directly from the manufacturer's catalog. When we work in real life products, we do not every time go about reinventing the basic things like devices like this, the heat sinks, and then devices like this, fans and so on. Similarly, most other things are taken, are adapted from plain old off the shelf items, commonly available off the shelf items. Advantage being everything has an alternate source, and only when things are in very large numbers or they are very what you call very specific, as in let us say if you need to send out a satellite, only one satellite will be finally launched, but when we start now, I think 10 of them are made anywhere. Even there is nothing like one unique thing, everything is a minimum batch is there. Such conditions, it is worthwhile reinventing everything, but even there if you see inside, the reference design for everything is already been tried, and then incremental things are done on how to package this and so on. So, part of this course has been what you call as exposed, rather I enjoy people being exposed to trade catalogs and then available things, and remember by just copying something from the catalog, it is unlikely you will come into any useful result. However, if you can source them and negotiate them and try to use commercially available things, you are much better off. That is what I was trying to say. all along in this. Now, I will check whether where I am in this and yeah. Okay, keep looking at it. Meanwhile, I will come here and see. Yeah, if you can see here, there are beautiful companies which specifically for the components that they make, they have gone out of the way and try to create things which are seen here, no, saying tremendous amount of material is there on the system overview design process, and important is how to choose a Peltier element, choosing a TEC controller. As I said, since we have this there all the time, it is much easier for you to examine these things and try to use them as you like, unless you are a completely what you call somebody who is very much, what you call, you have a little problem with these things, starting with very important things of what is the maximum temperature, what is the maximum current, and then how do the system things work, what is the design process, everything is very clearly mentioned here. You can always, this being a video thing, you can always try to go back and then check saying which is the maximum efficiency point, coefficient of performance when choosing a Peltier, the definition is be heat absorbed and so on and so on. No? So, this thing is this green line, no, it will give you what is the Q max and then which is the device you need to choose, what is the temperature and so on. No? I think one needs to consult these catalogs, because for every device there is much more than one manufacturer and their contracted specifications are very useful. So, practicing engineers will benefit probably by looking through all the items in the course, and one more time with both apologies and the reality is there are no equations which will solve the problem, but tests which see whether you have understood as concept, probably equation and multiple answers choice are useful like that. In reality, we only have products which work under given atmospheric conditions, and after it is fully packaged and put to test, you will know if the design is correct. So, we have failures occasionally, and in the case of your what do you call commercial items, like I am carrying audio or RF audio transmitter which is hooked there. You know very well it has to work, and in this particular case now it has rechargeable batteries, then it has a charger and so on and so on. Now you know that it has taken a long time for them to come. This manufacturer, I think well, and all of you people know about it, has been in this business forever. So, as a serious researcher, you can, in case there is a problem in this, one small problem, you can improve. Same thing it is with several things. I wear a in the canal hearing aid, costs a lot of money. This costs huge amount of money. I do not know, I mean your money, I have paid 50,000 Indian rupees for it. So, it is money. So, if I take something as a what do you call a dollar equivalent to 100 rupees, probably it is $500 US, and then in the US you may be spending $1,000 to have it in your ear. The thing is, everything including the power supply, including the audio, and then it has a 4-channel dynamic compounder type things, which are built into it, and then it is programmable. I have a switch, I can choose between 4 programs, 4 channels and so on. Now, they are all very complicated miniaturized things. The same heat transfer devices which you have there are also used here, and mind you, it has 2 what you call microphones, and it has built-in noise cancelling, and it has and both the ears, face control is there like that. This is the growth of electronics, and probably all the electronics which is inside here, including some equivalent to a Bluetooth is also built into it, all of them in 2 small chips, and it has a tiny battery. It is my life saving what you call devices. I thought I will just explain to you a little about how do we go around. You see here, this whole thing has been built on that, saying in the case of a practical device, how do you start with a enclosure like this and try to build beautiful equipment. So, the people from the academic community can benefit by just following all the references and see how best you can make use of the information that I have presented here. You see here at this point, I have used the commercial heatsink and tried to build an equipment. In the last lecture, how well can I make an equipment which looks like this. This is about the concept design, and secondly, most manufacturers' catalogs will give you, given a length, what should be the thermal resistance of the device. Further, if you want, basic equations, everything have been explained in the earlier chapters, and then I suggest you refer to the original textbooks. And we also have along the way we had one Professor Schonholzer who worked with us and made all these notes, thermal design of electronic equipment. So, maybe you should understand, just reading it a little more, recognize right at the beginning the exact calculations are not possible. Schonholzer has been around practically forever, since the problem presented are too complicated for total formulation. Therefore, we placed on finding simplified models times the knowledge about simple electrical circuits. So, if you go further down in the end of these notes, small worked examples and all are here. But then you will notice it that when you work with the small things like this, while the equations are about the same for both this and the monster, the actual conditions are not that easily available. You see here I have 2 heat dissipators, something fully black on both sides and something which has a cute area which is cleaned. So, does it have any effect? Does this what you call surface finish have some issue with it, or what is it? These things, my repeating will only take you somewhere. I think you should face the thing automatically and you will learn things like this. So, a lot about, there is a little controversial thing also between 2 of my lectures. You may find a little controversy, saying how does the bottom surface of a flat plate work, how does the top surface work, and then in case both sides are free, and then in case they are what do you call stacked together, there are various things which are mentioned here. Most important is, can you see here, this heat transfer coefficient in convection, lot of it depends on figures like this which are gathered empirically, saying for bottom sided it is 1.6, and it is for you to verify these things in your specific condition. Towards the end, I expect that you will be able to try and make equipment, and I can just say welcome to the course. I won't say welcome to the jungle or anything. Professionals will benefit by trying to go back to theory which is already presented, and also a few sources are available for the various components which we have mentioned. And engineering students or any physics students and all can understand saying where they have started 300 years back, and I mean come here. So thank you. I can say welcome to the course. This is again part of a large series. One of the first thing is about the basic conceptualization of the product. Second part is again the little focus on how do you provide a cooling solution, and then I have tried to show you very big things like a huge solar installation which is put by our government in a place which you will see the pictures if you follow the whole course. And then finally very very tiny thing saying how do you cool a small area using a peltier, and other non-conventional things. There is only a passing mention of heat pipes. Now, that is not very common. Same thing it is, even a very very what do you call transient mention of vapor chambers, but they are very real, and nobody should try to construct a vapor chamber. It is not easy. Similarly, you have called what you call jet impingement cooling and so on and so on. No? All of them have their own application which is not a very general nature. So basically something how to use simple forced cooling, something about how to use peltier is probably the most common that is used. And then occasionally you have the things like if you see a so called main processor cooler, you can see to improve the fin effectiveness what has been done, how the core has been what you call something has been removed, something has been put, so that over the end why this particular thing has a very peculiar shape here, why is this thick and then as it comes here. So I will stop here. I what do you call invite you to go through these things and continue with your area of research or construction or anything. And the only what do you call the answer to most of them is that you need to try it, and the closer you are it is the better. So thank you. I will stop here.